Hi and welcome to E-ZTutoring. Today we are going to cover how to evaluate logarithmic expressions. Now, before I go over how to evaluate them, I want to assume that you guys are familiar with this topic right here, and that is how to convert logarithmic form to exponential form. You need to know this before we jump into what we're doing now. If you're not familiar with this, I actually have a video about this on my channel, so be sure to check that out. But without further ado, let's jump right into it. Suppose we have log base 2 of 16. And we are supposed to evaluate this. We are supposed to give a number for this of what it's equal to. So this is going to be equal to something. So let's say it's equal to x. Generally, this x is not given, and you're given just this log right here. Writing down this x will make things a lot easier. Now here's why. You can't solve anything in the logarithmic form. You have to convert it to exponential form to understand what's going on. So we convert this and we get 2 to the x equals 16. So now all you need to do is find out what x is. Well, we know that 2 times 2 equals 4. Times 2 equals 8, times 2 equals 16. So 2 to the power of 4 equals 16. So therefore, x is 4. Easy enough, right? Generally, these you'll be able to solve by doing simple mental math. If you couldn't do it using mental math, you can write out 2 times 2 times 2 times 2 until you get 16. So let's go ahead and do some more examples here. Suppose we have log base 3 of 1 over 81. Okay, so once again, we need to set this equal to something. We'll say x, and we have to convert this to exponential form. So we do our 2 arrows, and we get 3 to the x equals 1 over 81. So this is where things get a little bit more complicated, because you can see we are going from a 3 to a fraction. Now, I'm also going to assume you guys are familiar with negative exponents. If you guys aren't familiar with that, be sure to check out my video on all the different exponential rules. But anyways, we need a negative exponent for 3 to become a fraction. So you can either do this using mental math and just make the exponent negative, or you can actually switch this around and we can say that 3, I'll write this over here, 3 to the x equals, instead of 1 over 81, we'll flip this and put a negative on its exponent, and we'll say negative 1. So now we can do our mental math here and think about how many times we need to multiply 3 to get 81. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the power of 4 is 81. So we will say 3 to the power of 4 equals 81. And once again, we cannot forget about this exponent here, negative 1. So 3 to the power of 4 is really 81, but without the negative 1 as the exponent. So in order for these to be equal, you need to put a negative 4 here as well. Another way to imagine this, instead of saying 3 to the x equals 81 to the negative 1, you could say 1 over 3 to the negative x equals 1 over 81. And then when you do your mental math, you could say 1 over 3 times 1 over 3, and so on. But either way, that is how you go about negative exponents. Let's go ahead and do some more examples here. Okay, so now suppose that we have log base 11 of 11 to the power of n minus 5. So once again, we have to set this equal to something. We'll say x. So we can convert it to exponential form. So we go ahead and do that, and we get 11 to the x equals 11 to the power of n minus 5. So by looking at this equation, we notice something. 11 to a power equals 11 to a power. So therefore, those two powers have to be equal. That is the only way this equation could possibly be true. So x must be equal to n minus 5. And just like that, you found your answer. You can actually do a shortcut here, and whenever you see that these two numbers are the same, the base and whatever's inside the logarithm, your answer will always be the exponent over here. Okay, so let's go ahead and do our last example here. Suppose we have 6 to the power of log base 6 of 3x plus 2. So before I jump into this problem, I would like to go over a simple logarithmic rule here. So I'm going to make some room on the board here. So this rule says that b to the power of log base b of x equals x. Now this rule is very important to know when evaluating logarithmic expressions. Pretty much, if you have a number to the power of a log and that log has a base that is the same number, then your answer will just be whatever's inside the logarithm, x. So in this case, that's exactly what's happening here. We have a number to the power of a log, and that log has a base which is the same as this number. So these two being the same is very important. So whenever that's the case, your answer is simply whatever's inside there. So this will actually be equal to 3x plus 2. And just like that, you found your answer. So I went ahead and covered all of the different topics that you will see when evaluating logarithmic expressions. For ACT or SAT help, be sure to visit www.E-ZTutoring.com. Hope you guys understood this, and good luck.